Good day, everyone. I am Daniel John Pipito from Cebu Technological University, Naga campus. So today, let's talk about binary and to decimal conversion. So first, what is a binary? So what is a binary? A binary is a base 2 system, and it only contains value of 1 and 0. So 1 is an on state. It means that 1 is the only value that the computer reads, and the 0 is the off state. So for example, 101011. So that is a binary base 2 system. So what is a decimal system? So a decimal system is a base 10 system. So it means it contains value of 0 to 9. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then, for example, 24. And this is a base 10 system. So today, we will convert binary to decimal. So, as you can see, um, we have 1, 0, 1, 1, 0. It's a base 2 system. It is a binary. So let's convert it to decimal system. So first, let me erase this. So first, we have to put this power of 2 table. So let's start with the right side to left. So let's start with 2 with the power of 0, and 2 with the power of 1, 2 with the power of 2, 2 with the power of 3, and 2 with the power of 4, and so on. So for that, since we have 0, and this is an off state, we can invalidate this. So just erase this, that. So okay. So since 0 is an off state, we can erase the 0, and we only need the value 1. So for the equation, we only get these 2 raised to the power of 4, and 2 squared, and 2 to the power of 1. So we have this. So remember, guys, that the power of 2 table, which means that 2 to the power of 0 is equal to 1, and 2 to the power of 1 is equal to 2, and 2 to the power of 2 is equal to 4, and so on. So since we have 2 to the power of 4, we have this, and 16 value, so we have 16. And then the 2 squared, we have 4, so we have this 4, and 2 to the power of 1 is 2. So when we add that, guys, we have to come up a value of 22. So since this is already a decimal, so we have to put this base 10 system. So this is our answer, guys. So for the checking, we have this 22, right? So it is a binary, so we have to divide it by 2. So we have to come up by 11. So we have no remainder, so remainder is 0. So 11, we have to put this and divide it by 2. So we have 5, so we have a remainder 1. So 2 times 5 equals 10, so there's a remainder 1. So we have to put this remainder 1. And then the remainder is the important thing of this part, because if they identify our binary system. So the 5 divided by 2 is equal to 2. So 2 times 2 equals 4, right? So we have a remainder 1 for 5. So we have to put that. Then 2 divided by 2 equals 1. So we have no remainder, so it means it will be 0. So 1 divided by 2 is equal to 0. So we can divide it by 2 to the 1. So we have this remainder 1. So if the value of the equation is 0, so that's the time that we will stop dividing the numbers. So for the reading of this, guys, so we have to read it upward. So we have the 1, 0, 1, 1, and 0. So we have this. So as you can see, we've come up, we've checked the binary system. So it is right, our equation is right. Okay. So today, we will proceed to binary with decimal point. So this is the decimal point. So for the decimal point, we have this. So for the decimal point, for this part, our exponent is from right to left. But in the decimal point, our exponent is from left to right. So we'll start with this whole number. So for the whole number, we have 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2. Since we have 0, it will be an offstate, so we will disregard that 1. So we will only get the 2 squared and 2 to the raised to the power of 0. And for the decimal point, we what do you call this one? So we won't start with 0. Instead, we will start with negative 1. So for this negative 1, 0 and 1 is for the 2 raised to the power of negative 2. So this is a fraction, guys. So when we mean fraction, we have this what do you call this one? So since this 2 raised to the power of negative 1, it is 2, right? So 2 over 1. It is a fraction, guys. So when you divide it, guys, you will be come up with this answer. So if 2 raised to the power of negative 2, it will be 4 over 1. So this is the equivalent decimal number. So let's proceed. So since we have this, we cancel this, so we only get 2 and 0. And for the decimal, guys, we also cancel that 0 since it is an offstate, so we only get this 2 raised to the power of negative 2. So 2 squared is 4, and 2 raised to the power of 0 is 1, as you remember for the last topic. Then for the 2 raised to the power of negative 2, it is 0.25. So when we add up that, guys, so we have 5.25 and a base 10 system, since it is already a decimal system. So for the checking for the whole number, same for the last, 5 divided by 2 equals 2, and we have a remainder 1, and 2 divided by 2 equals 1, so we have a remainder of 0. Then 1 divided by 2 equals 0, and we have a remainder of 1. So we have this whole number. For the checking for the it is wrong. Disregard this, guys. So for the checking of decimal numbers, so we have this 0.25. So 0.25, we will be multiply it by 2. We will multiply it by 2. So we have this 0.5 and the remainder of 0. So for that 0.5, multiply it by 2 equals 1. So when the value of this gets to a value of 1, we'll stop the multiply. So we have this remainder 1. So if this value has decimal point, so for example, it will be 1.5, we will continue multiply it, but we only get this 0.5, and the remainder will go here. So So if the value is already 1 without decimal point, decimal numbers, so we will stop that multiply. So for that, for this whole number, we read it upward. But for the decimal numbers, we read it downward. So we have this 0, 1 and 1, 0, 1. So 101.01. So we check the binary. So our equation, our computation is correct. So that's all, guys. Thank you.